Assalamualaikum warahmatullahi wabarakatuh. We continue back our lesson, about specific heat capacity. Hopefully you understand the equation of Q is equal to MC delta T. We discussed about it before this in our previous lesson. How do you get Q is equal to MC delta T? I showed to you how to derive the equation by using heat capacity and specific heat capacity. Now you have to remember this equation. What is Q, what is M, and then C, small c stand for specific heat capacity, and times delta theta, the difference in temperature. Alright, we go to the next page. Look at the explanation here. This is the example. Alright, we start here. Look at here. Alright, look at the first one, this one. Here, the first one. The example of A is aluminium. The substance is aluminium, where the mass of aluminium here is 1 kg, B is copper, and C is plumbum. All of substance have the same mass, which is 1 kilogram. Aluminium needs, look at the explanation here for A. Aluminium needs 900 joule of heat to increase 1 Celsius degree in temperature. Now look at B. Copper needs 890 joule to increase the heat to 1 Celsius degree. And then plumbum needs 130 joule of heat to increase 1 Celsius degree in temperature. So here you can see here, A, B, and C have equal masses, but different of amounts of heat are required to raise the temperature by 1 Celsius degree. That means here, different materials are said to have different specific heat capacity. Have a look at A first. A needs, substance A, which is aluminium, needs 900 joule. 900 joule. 900 joule means this is the amount of heat. 900 joule is the amount of heat is required to increase the temperature of the aluminium to 1 Celsius degree. That means 900 joule is the value of specific heat capacity. While copper is the value of the specific heat capacity is 890 joule. And then plumbum, the value of specific heat capacity is 130 joule. Alright, this material, this table shows the value of specific heat capacity for different substance. Can you see it? The table here. Hopefully you can see it, or you can refer it to reference book. Look at here, substance here. They list the substance here: aluminium, alcohol, copper, and until here is protein. The last part is protein. So look at here, this is the value of, look at this column, alright? Look at this column. This column shows the value of specific heat capacity for each of the substance that is listed here. So you don't have to remember all this value because you are given this value, or you are asked to find the value. Now let us do some example here. Alright, let us see example 2. How much heat must be added to 3 kg of water to raise its temperature from 20 Celsius degree to 80 Celsius degree? So how much heat? That means you have to find Q. You have to find Q. So Q here, this Q Q is equal, okay, wait. Q, oh, 2 ticks. Remember the equation, Q is equal to MC delta T. This is small c. And then here M is 3 kg. And then C here is 4200. Okay, 4200. This is the specific heat capacity of water. And then the difference in temperature here. Okay, the difference in temperature here is 80 minus 20. Okay, so you can calculate here, you can get the answer here. What is the unit for Q? Don't forget the unit is joule. Alright, we go to the next example. Still the same. We still use the same equation. Okay, cold water at temperature of 15 Celsius degree enters the heater and the resulting hot water has a temperature of 61 Celsius degree. So this is the initial temperature. This is the final temperature. Okay, wait. Okay. The mass. A person or users 1 to 0 kg of hot water in taking a shower. Find the energy needed. Okay, find the energy needed. You can see here the energy needed. That means this is the energy needed to heat the water. That means this is the amount of heat. Q, the amount of heat. Okay, if we want to find the rate of Q, we still use the same equation. Q is equal to MC delta T. Write the equation. Write the equation. Here, for example, here, you can get 1 mark for the equation. So, don't forget to write the equation. Okay. M here is 120 kg. Okay, the unit for mass. Use the SI unit for mass, 120 kg. And then see here, okay, you are given here the specific heat capacity is 4186 joule. Okay, use the value that is given to you. And then delta T is 61 minus 15. Okay, so when you calculate here, you will get 2.3 times 10 to the power of 7 joule. Try to calculate it. Okay. Alright. Then we go to the next one. Okay, example. Okay. For the example 4, I want you to do the exercise yourself. Okay. This one you should submit it through Google Classroom. Okay. Question number 1. Okay, the question that you have to submit it. This is the first one. Alright, don't forget. Okay. Now we go to the thermal equilibrium. Okay, what is thermal equilibrium? Thermal equilibrium. There is no net flow of heat between two objects. Okay, no net flow of heat. This is the explanation about the thermal equilibrium. Two objects have the same temperature. Two objects in contact. Okay, two objects in contact. At this stage, the bodies are said to be in thermal equilibrium. Okay. Have a look at this example. Okay, look at here. There are two objects here, object block A and block B. You can see, as you can see here, block A here and block B. There are two objects, two substances, for example. So block A is hot compared to block B. Okay, the temperature of block A is 98 Celsius degree and the temperature of block C is 27 Celsius degree. What will happen if the two blocks are in direct physical contact? That means it is touching. Okay, both of them are in contact. Okay, so when you put both objects in contact, okay, heat is transferred at a fast rate from hot objects to cold object. Okay, hot object to cold object. Heat is transferred. Remember the definition of heat. Heat is transferred from high temperature object to low temperature object. So similar to this, okay, heat will transfer fast from block A to block B. And then heat is transferred at a slow rate from B to A. Okay, what will happen next? Okay, what will happen next? What happen after some times? What will happen after some times? I mean, for example, here after 5 minutes, for example, okay, after 5 minutes, okay, what will happen to both objects? What will happen to the temperature of both objects? Okay, look at here. So both objects, okay, will reach the same temperature. The temperature here, so this situation is called thermal equilibrium. That means block A reached the temperature of 37 Celsius degree and block B reached the temperature of also 37 Celsius degree. Okay. Okay, the net, look at the explanation here. The net rate of heat transferred between two objects become 0. That means there is no more the transfer of heat between the two substances. Okay, so this condition is called thermal equilibrium. That means both objects that are in contact reach the same temperature. Okay. Now we go to the calorimetry. Okay, calorimetry, that means, okay, let us see the definition first about closed system. Okay, closed system means no mass enters or leaves but energy may be exchanged. Okay, and then kalau open system, okay, mass may transfer as well. Okay, isolated system, there are three different things. Okay, three different things: closed system, open system, and isolated system. So for the isolated system, closed systems where no energy in any form is transferred. There is no transfer of energy. Okay, let us see here. Okay, let us see the explanation here. When different parts of an isolated system are at different temperature, heat will flow from the part at higher temperature to part of lower temperature. This explanation you should know because this is the explanation of heat. So for an isolated system, the heat loss by one part of the system is equal to the heat gain. Look at this. What we call the important point here. For an isolated system, okay, the heat loss by one part of the system is equal to the heat gain by the other part. Okay, so here you should know how to use, you should know which substance lost the heat and which substance gained the heat. Okay, now I don't want you to use this. Look at this equation. Okay, look at this equation. Okay, all right, this equation. Okay, I prefer you to use this equation. Let me write it for you. Okay, so heat gain, Okay, you can use this equation, but another one, you can use this equation. This is correct actually, but to make it easy, I want you to use this one. Okay, look at this one. Okay, for isolated system, heat gain. Okay. Right, for an isolated system, heat gain plus heat loss is equal to 0. So here the equation becomes heat gain is equal to minus heat loss. Okay, I want you to use this equation. This one, this one. Actually, it's optional for you to choose to use this equation. Okay, this equation or this equation. What is the difference between these two equations? Okay, as you can see here, okay, at this part, okay, at this part, you can see here there's a negative minus here. Okay, minus sign. When I rearrange the equation, there's a minus sign here. For this equation, there is no minus sign. That's the difference. Okay, what is the difference? Okay, so you should know heat gain. Heat gain is equal to this one. Heat gain is equal to mc delta T, where delta T here is final temperature minus initial temperature. Okay, heat gain. For the heat loss, the difference is for the heat loss. Okay, heat loss is equal to mc delta T, and then here is initial temperature minus final temperature. So you should remember the difference here for heat gain and heat loss. This is for those who want to use this equation. Okay, so some book they write this like this, and some reference books they write like this. So both can be used. Okay, and both are correct. That's no problem. Okay, for this one, okay, I expand the equation. Heat gain here is equal to mc, here is final temperature minus initial temperature. This is for the heat gain. And then for the heat loss, minus, okay, mc delta T. Delta T here is also final temperature minus initial temperature. This is for the heat loss. Okay, so you can see here. Okay, it's easier. Okay, become easier because the difference in temperature for both gain and loss are same. Final temperature minus initial temperature, and same with the heat loss. Okay, it is always the difference in temperature is always final temperature minus initial temperature. This is for those who want to use this equation. But for those who want to use this one, another equation, this one, okay, you should remember that heat gain, final temperature minus initial temperature, and heat loss, initial temperature minus final temperature. That's the difference. So for me, I prefer to use this equation. Heat gain is equal to minus heat loss, because I don't have to remember about the difference in temperature, because the difference in temperature is always final minus initial temperature for gain and loss. Okay, hope you clear about this one. All right, next. Okay, so if you have a chance to go to your laboratory, you can see the calorimeter. This is the calorimeter cup. Okay, you can see here, this is the calorimeter cup. Right, the instrument to the below. Okay, the instrument below is a calorimeter. We call it calorimeter, which makes quantitative measurements of heat exchange. A sample is heated to a well-measured high temperature, plunged into the water, and the equilibrium temperature measured. This gives the specific heat of the sample. Okay, okay, this part, this we call it calorimeter part, a cup, sorry. And there's an insulating jacket here. This is to prevent from heat from loss to surrounding. Okay, next, have a look at the example here. Okay, you can see the example here. Okay, first you have to identify the question whether the substance, that means the number of substance, okay, the number of substance that is involved in your calculation. Okay, look at here. A 200 copper calorimeter contains 154 gram of water at 20 Celsius degree. A 254 gram of aluminium at 100 Celsius degree is added to the water. What will be the temperature of the system after equilibrium is established? So here you can see here there are three substances, which is copper calorimeter, number 1, number 2 is water, and number 3 is aluminium. Okay, so that means there is some substance will gain the heat, and another substance is lost the heat. So now you should identify which one gain the heat and which one lost the heat. Okay, this is, for example, okay, I draw the diagram so that it easier for you to understand. Copper calorimeter. This is copper calorimeter. Okay, and then inside it, it contains water. Okay, so this is copper. So Cu, I put the symbol Cu is copper calorimeter, and then inside is water. So what is the initial temperature of copper and water? 20 Celsius degree. This is the initial temperature for copper calorimeter and water. And then another substance, aluminium at 100 Celsius degree. So this is aluminium at 100 Celsius degree. So the initial temperature of the aluminium is 100 Celsius degree. So this, for example, here is the block of aluminium. This block of aluminium is put inside the copper calorimeter. Okay, so what will happen to the final temperature after, for example, after sometimes, okay, both substance reach the same temperature, which we call it thermal equilibrium temperature. So you are asked to find the thermal equilibrium temperature. So what will happen when the aluminium is put inside the copper calorimeter? So which one gained the heat and which one lost the heat? So from here, by using your logical thinking, you can explain which one gained the heat and which one lost the heat. So copper and water will gain the heat. Why? Because look at the temperature of the aluminium. The initial temperature of the aluminium is bigger than the initial temperature of copper and water. Okay, so copper and water will gain the heat. Okay, so the substance that lost the heat is aluminium, lost the heat. So after knowing which one gained and which one lost, it's easier for you to write the equation. So again, remember we will use the equation of heat gain. Heat gain is equal to heat loss. Oh, sorry. Heat gain is equal to minus heat loss. Don't forget to put minus heat loss. Okay. For me, I prefer to use this equation. Okay, it's up to you. You can use heat gain is equal to heat loss without minus sign, but for me, I prefer to use minus sign. Okay, so gain the heat is, remember, water and copper. So Q water, heat gained by the water plus heat gained by the copper calorimeter is equal to heat loss by the aluminium. Okay. So here we expand the equation. It's become M water, C water, and then delta T. Delta T here, okay, the initial temperature is 20. So final temperature minus 20. And then plus M copper, okay, C copper, then delta T here is the same with water, because they are in contact, okay, is equal to minus Q aluminium, M aluminium, C aluminium, and delta T here will be final temperature minus 100. Okay, so substitute all the value here. You substitute M water here is equal to 150.15. Okay, remember, use the SI unit. So you are given in gram, so you have to convert it in kilogram. Sea water is 4200. Okay, 4200. Then final temperature, the temperature that we want to find. Okay, plus M copper 200, 0.2. C copper, okay, C copper is 390. Okay, and then times, okay, I continue here, okay, times final temperature minus initial temperature is equal to minus M aluminium is 250, so 0.25 kilogram. C aluminium is 900, and here is final temperature minus 100. Okay, so now you can calculate. There is only one unknown here. Okay, there is only one unknown here. TF, TF, TF. TF means final temperature. So therefore, okay, therefore, final temperature is equal to, you have to calculate it yourself. Okay, so the answer here is correct. Try to calculate it. Okay, try to calculate it. Alright, this is the step. I show you the step. Okay. And then example 6. Okay, for the example 6, I want you to do it yourself. To do it yourself. This is the second question that you should submit it to me. Okay, the first question is question number 4, example 4, and then example 6. Example 6. Okay, so we stop here and I will continue on latent heat for the next lesson. Okay, see you again. Assalamualaikum warahmatullahi wabarakatuh.